All right, good morning. Welcome. No matter what time of day it is for you, it's morning for me. Let's see. Go just a tad higher. I'll try to speak up as well. If it's too loud, let me know. I can shrink it back down. So first of all, welcome and thanks for watching. If you are new to the stream and you don't know, haven't caught it before, my name is Tim. I go by Foamy Guy. Online on GitHub and Discord, and on the stream at this time each week around 10 a.m. Central Time. We are here working on some CircuitPython related stuff. If you don't know what CircuitPython is, you'll learn more about it at the main website for it, circuitpython.org. This is basically a version of Python that runs on tiny computers called microcontrollers. There's a bunch of pictures of them over here today. I have the Metro RP2350. But basically the way CircuitPython works is these tiny computers on the chip that is on these devices. If you choose to run CircuitPython on it, it can do other stuff as well. But if you choose to use CircuitPython with it, then when you plug it in, usually with a USB cable to your computer, it shows up like a thumb drive. You can edit a Python code file on that thumb drive. And then when you save it, the microcontroller, the computer inside the chip, will actually interpret and run that Python code for you. And then microcontrollers are often general purpose devices, so they have lots of GPIO, general purpose input-output pins, like these ones have along the sides here in this Arduino Uno form factor. You can then hook up whatever other hardware you want and interface with it from your Python code, like displays and sensors and buttons and RGB lights and pretty much any kind of little electronic device you can hook up to one of these microcontrollers and then interface with it, whether that's like read data from a sensor or output data to some other thing, send it to the internet, whatever kind of thing you can dream up, really. That's the high-level version of what CircuitPython is. As always, huge thanks to Adafruit. Adafruit is a hardware and software company based out of New York. They're the ones who make CircuitPython possible by paying the team of folks who work on CircuitPython, including myself. There are a couple of other folks on the team who work full-time on CircuitPython and related stuff. Adafruit pays them to do so. There are some folks in the community who work part-time on CircuitPython and guides and other related things. All of that work is greatly appreciated, as is Adafruit for paying everyone for doing it to make all of this great stuff possible. They sell not only the microcontrollers themselves, like this Metro RP2350 that I'm using today is an Adafruit design and manufactured hardware that you can purchase from their site, although they may be, I don't know, are they in stock right now? Let's check. It's fairly new, so it may be out of stock. Yeah, looks like it's out of stock right now. The Feather is in stock, the one without PS RAM, which is fairly similar. You could do a lot of the same stuff that I'm doing today on the Metro. You could also do it on the Feather. But yeah, thank you as always to Adafruit. Thanks to everyone who purchases hardware from them so that they can pay us to make all of the rest of this stuff keep going. Today, I am looking at a snake game that I made a while back, and we are going to try to bring it into the Metro RP2350 like I was talking about. So I have a 2350 set up here. It's got the HDMI cable set up, the DVI output through the HSTX. So we'll go through some of that stuff. Let's see, maybe pull up the Metro page again here just so we can get some different photos. See some of this. So on the bit, and the camera that I normally show you, the device that I'm working on, is actually showing the screen right here. So I can't really show you my Metro that it's hooked up to. But this ribbon cable connector here, HSTX, this thing is for connecting to a DVI output. So there is another little breakout one, this thing here. Interesting. But that one's face up. Do you not have to put the? Does it matter which way you? Anyway, let's not dive too deep into that curiosity of mine. Anyway, though, so this is the DVI breakout. You connect that to the HSTX port using this ribbon cable, and then that gives you an HDMI shaped plug, which you can plug into most standard televisions and stuff that have HDMI inputs, and it will play. I guess it's technically DVI inside there or something. I don't know the particulars, but I do know that it has an HDMI shaped plug, and when you plug it into a TV, most TVs, certain TVs, at least this TV right here and lots of the TVs that I have, they show whatever's coming out of it. And so that's hooked up. And then one of the other cool things I wanted to show, actually, before I dive straight into my own stuff today, is the code that is running on this. This is a new-ish thing. I think we have Jeff to hug report for this. So this code here, what you will notice, one thing about it, there's no display setup. There's no release displays, there's no initialize a display, there's no draw to the display, there's nothing about displays in this code. And it is still working on the device. And even, I think, if I were to reset, let's make sure that I'm actually being real here. So I'm going to unplug this and plug it back in, which I can do with a button on my desk here. Yeah. So we have no initialization here, and I believe this is a newish thing, basically, that Jeff just did recently in CircuitPython, where the Feather 2350 and the Metro 2350 that have their HST exports, they essentially get like a built-in display that goes out there, so you no longer need to like initialize the frame buffer display and do the release displays and do all the stuff. Instead, it just comes up, and it's kind of like board.display always was on devices. Although I do think also they changed that. Maybe it's no longer board.display, I think. Is that right? Let's make sure. So I think it is no longer board.display. Yeah, would be right in there. And instead, I think now there is supervisor.runtime.display. And that references the display. So that would be where we could go and set the root group to something else, and then that whatever else would then show on the TV there. So that's super cool. I just wanted to point that out and say huge thanks to Jeff. I think that's really cool that we can have the HDMI display just auto set up and then start pumping out whatever would be on the screen if there were a TFT or any other kind of display setup. So cool stuff. Also makes your code go faster, kind of, and less like kind of flashy on the screen, because you no longer need the release displays, right? You can set this up and then, or you don't even have to set it up. It's just kind of done for you, and you don't have to release displays in your code anymore. I think I need that HDMI board still. Got the cable only. I got you. Yeah, the breakout, the little breakout adds. There is the Feather. There is a Feather RP2350 which has the HDMI just directly, the HDMI plug just directly on the end of the Feather there. And then of course the upcoming Fruit Jam has HDMI plug as well, so you don't need the ribbon cable or the breakout. You can just go straight. It's definitely nice. Okay, so today's exercise, I think, is we are bringing a snake game into this. I did actually work on this game a while back with Katney for a conference badge. I think she was going to PyCon, perhaps, or one of the other conferences, and wanted a badge with a couple of things on it. One of the things was a little snake implementation. And so I do have this. It is made for a PyBadge device, so it's not just going to work right away, and it's also got some stuff. I don't know if we'll use everything, but basically we're going to bring this over and get it running on the Metro, and then if that goes well, I will start kind of tinkering around a bit, because I have some ideas for different things we might be able to do with it. But let's get it working first, and then worry about what's next. And I am just going to clone it, because I probably don't have this code on my local computer right now, because this was before the last time I started over on my computer, basically. And the absolute first step I'm going to take is actually just walking through the code real quick, because it's been a long time since I looked at it. Man, it's been a long time since I looked at it, so I want to get my head wrapped back around it, and this will also serve as a way for anyone who's watching is interested to see what the code inside of it is. It's called PyBadger. CircuitPython PyBadger snake. So it is broken up into like a CodePy file and a helpers file, which contains a couple of classes that the CodePy file uses. So I'm going to go through the classes first. We have a snake class. It's got direction constants for up, down, left, right. It gets initialized with a starting location. This doesn't like the fact that I used a list instead of, I think, a tuple here probably. Let's not change the code just yet, but that's probably one thing we could change. It adds the starting location into a list, so we ultimately have, I guess, a list of lists. And currently, inside of a init, at least, it only has one thing in it, which is the starting location. A direction gets set randomly. So those are numbers. We can use randint to choose a random one for us. We go a random direction. We have a grow function. If we are going in the direction of up, so if our current direction is up, then we say the new segment is the location of the tail and the location of, the X location of the tail and then the Y location of the tail, but one higher than that because we're moving up. So basically, no. That's tile grid. I think that's tile grid coordinates, not pixel coordinates on the display. So actually up is down, I think. We'll see later. But I think that's tile grid coordinates, so that's further down, south on the display. We're moving up. And then we're going to make the new segment of the snake basically after the end of the tail. Then when we're moving down, it's the exact opposite. We're going to make the new segment after the end of the tail, but because we're moving down, after is now up one cell from the tail versus down one cell from it, based on which way we're moving. Left and right are the exact same way, except it's X that is manipulated instead of Y. Then we put the new segment into our list of segments. So basically we store a list of XY coordinates within a tile grid. Each one of those coordinates is one segment on the snake. I don't know, that doesn't look like it needs to exist. Size returns the length of the list. Length also returns the length. Head returns the XY coordinates of the head, the first segment, which is the head. So it looks like the segment at index 0 is the head. The segment at index, -1, the last one in the list, is the tail. Is what we have here. Okay, so that's it for the snake. The snake has a direction. It has a grow function. And that's it. It has head and tail accessors for getting access to those things. Those are just convenience, though. Realistically, you could just use locations. And it has a size. Okay, so not too much on the snake. World is extending tile grid. It has indexes, sprite indexes for each possible type of tile. So empty with a snake segment and then with an apple. This gets initialized with a height and a width. Those are in tiles, not pixels. It says sprite sheet bitmap, load that, make 0 transparent, call super init, so we're extending tile grid, so we're calling the tile grid init, we're giving it the bitmap of sprite sheet bitmap, we're giving it the pixel shader there. Height and width is the ones we got from here. Tile height, tile width, it's saying these are 8 by 8 pixels for these tiles. We may change that because we have a bit of a bigger display, but let's leave it for now. Default tile 0, so when this tile grid gets created, all the tiles will be set to 0. draw snake for location in the snake locations. So loop over those XY coordinates, and then update the location within the tile grid. So in tile grid, you can say, 0, 0 equals, and then a sprite index. So that's saying for each location in the snake, set that location of the tile grid to the snake sprite index. And that is drawing the snake. So that will just go through, plot all the snake locations. Move snake. Previous location is set to the head. Next location is initialized to the same as previous location. If we're going up, then okay, so this is checking if we hit the wall, basically. So if we're going up and if our head is greater than 0, yeah. If it's greater than 0, then that means we have not hit the wall. And so in that case, we are going to minus 1 to go up by 1 cell of the tile grid. If it's not greater than 0, then we have hit the wall. So we raise game over. If we're going down, this is the same logic but flipped. So basically, if we're still in bounds, take a step forwards. If we're not still in bounds, game over. Left, if we're still in bounds on the left wall, take a step. If not, game over. Right, check the right wall, move a step, game over if not. So that also updated our next lock. So I said take a step, but really what happened is all we did is manipulate next lock. Next lock is a list here that was originally storing the location of the head. All we did so far is actually just change the X and Y locations in there. Realistically, the X or Y, not both probably. So we've changed those. Now we're going to go and say, if that location where we've got that set to now has an apple at it, then we insert that location into the snake at the 0 index, which is making it the head, the new head basically, so that where the apple was now becomes the new head of the snake. And then it says self.add apple, and that passes in the snake. So we haven't seen that function yet, but it's probably down further in world. Okay. So that's all if we ran into an apple. If we ran into a snake tile, so if we ran into ourselves, if we looped back around and hit our tail, game over. Else, so we didn't hit an apple, we didn't hit ourselves, then we actually go and take the step. So set the location, set the head location to next lock, which we changed up here. Then we go through and loop over all of the rest of the locations. Yeah, all the rest of the locations, because we skipped 0, although this is, well, I don't know, it's one way to do it, I guess, it's fine. So we skipped 0 because we already updated it here. But for every other index in the locations, we save a temporary variable with that location. We update the X coordinate to the previous X. We update the Y to the previous Y. And then we update the previous to the temp. So previous started out all the way up here. It was originally the head segment. So this is going and saying basically for each location, it's going to kind of become the one that was behind it or in front of it. HSTX to HDMI DVI breakout. Yep, we have the breakout with the ribbon cable running over to the TV. Okay, so each segment basically becomes, well, like, kind of gets the location of the one that came ahead of it in the chain. Previous always gets updated to temp, which makes it so that next time we go through this loop, previous is now the one we did last time, so that will keep going until the end. If we're on the last segment, then we update the previous lock, the place where the last segment was before the snake moved. We update that to be empty. So after the end of the tail, basically, all the segments of the snake are going to move by one cell, which means where the very tippy tip end of the tail used to be is going to become empty. Then we draw the snake. So we go and update all the locations, then we draw the snake to render it on the screen. Add apple takes a location, takes a snake. If the snake is run none, then it raises an exception. Maybe that should just be a not a named argument, maybe? I don't know. While location is none or location in... Okay, so this is just getting random locations and making sure that none of them are currently like colliding with the snake. We don't want to spawn an apple on a cell where the snake already is. So we keep finding random locations until we find one that's not on the snake. And then once we do, we update it to be the apple sprite. And then we have a game over exception, which is just a special exception we can raise when we need. Okay, so that's it for helpers. So CodePy says we have state machine variables for playing, paused, game over, and title. Current state, we start on title. Time step, I am guessing that's how long in seconds between each game tick, but I don't know. We'll see. Last button time, so that's probably the last time we pressed a button down. Button cooldown, that's probably how long until the next button press will register. So like basically to avoid it kind of counting you for pressing up twice if you didn't really mean to. You really kind of pressed it once, but it just happened to read fast enough that it was still down when it checked again. Initial snake length. Okay, board.display. So there's like a title image that's going to get shown. We create the world. We choose the starting location. We call grow equal to the number of times of the starting length, -1. So ours was 3. We have the head by default, which is why we have -1. So we go 2 times and call grow to get our snake to be 3 segments long. Grow basically just, added the new segment at the end of the list. We add the apple, a first starting apple to the world. We have a game group, we append the world to it, we show it, old API, we draw the snake, we read the button values, we set a timestamp, we get a new timestamp, so inside main loop, we get a new timestamp, we read the button values. If we're in the playing state, if the cooldowns on the buttons have elapsed, if the button was pressed, change the direction of the snake. And then there's all 4 directions. Update previous so that we can compare. If the start button was pressed, then we pause the game. Or we change the current state to paused. Game time step. So yeah, that was our 0.5, I think. So this is gonna kind of like do 1 tick of the game. So it will move the snake. It will update the game time step. So basically it looks like it's going to get faster as you progress. if the game ended, then we print some stuff, the score, play again, set the state to game over. So all of that was if we were currently in the playing state. If we're in the paused state, then pretty much nothing happens except we check for the button to unpause. If we're in the game over state, it looks like this is launching a different code file. Previous button start, supervisor reload file. I mean, that seems like it's going to relaunch this file, though. I'm not sure on that one. Select will reload, which will basically go back to CodePy. So in this one, there was CodePy, and then there was Code Snake Game. CodePy could launch Code Snake Game, and then Code Snake Game could go back to CodePy by resetting the device. So that's what these three are, and then it seems like this one will actually just restart the Snake Game. If we're on the title, if any button was pressed, show the game, set the state to playing. Update for the previous values. That was actually already done if we were in... Was it? I thought it was, maybe not. Oh, yeah, it was, if we're here. But then it calls continue, so it doesn't do the rest of the stuff, I guess. Okay. Okay, pretty straightforward. All right, so for sure, we will do this differently. See, we could copy the splash in. Checkers. This is now root group equals I don't think it should be none, though. I think this is trying to go back to the terminal, which actually should be display.io.CircuitPython terminal. Okay, where else do we have show game group? That should be root group. Okay. And then the controls are not going to work at all. Don't want this. So the way I'm going to do the controls for right now is actually this. Read serial bytes available. If there are some available, then read it from std in. And this basically will allow me to use my keyboard on my PC, which is connected over serial, but it would also work with a USB host keyboard plugged in to the device, I believe. I have tried connecting USB host keyboard to my Metro, and I have not gotten it working, but I understand the folks, some of the folks who have the Fruit Jams already have gotten some USB stuff working very recently on there. So I don't know if I need to update or if the other hardware is in place and the Metro is not currently or what, but so far I am not having success on the Metro. But this is really nice, actually, because when the USB host keyboard is picked up successfully by CircuitPython, when you press buttons on it, it will send them to the serial, standard in, which is convenient because that makes it so that I can develop a game testing on my keyboard on my PC, but then deploying with the keyboard plugged straight into the device. So this is what I'm going to do for now. Ultimately, we could also use game controls, the library I worked on a couple of weeks back, for using USB controllers or other things like the little stemma game pad. I have some of the Wii nunchuck breakouts on the way. So Wii nunchucks may be a future controller as well. But for now, it will be the serial stuff, and I don't think that... Trying to think for a second. I don't think we need the previous... I don't think we need the previous button values anymore to do it the way that I'm going to do it here with the supervisor. When we got back to a controller or something, it might make sense. But for this keyboard that I'm going to be doing here, I don't actually think we need this. And we're also then not going to do this that way. And instead, what we are going to do is basically this. I didn't mean to Alt-Tab there. I meant to Alt-Tab to the other file, not the other instance. But we will need sys. And I will call that cur button, I think val, because I think in the context of this game, it's always going to be one thing. Like, basically, I'm going to use WASD, and the user is going to be pressing one of them or not, and it will just print that one into standard in, I think. So we'll see. Maybe it can do... I don't know what will happen if we have two buttons down, I guess. We'll see. I'm going to change it to singular for now, though, because I think it will hold a single character most of the time. If we are playing cooldown, we could keep that for now. And then this part we just really won't have. Well, we will, but it's different. So we're not going to compare to previous. Instead, we're going to say if cur button val is equal to, so this is the up button, we're going to say W. Actually, truth be told, the WASD that I use, I actually go offset by 1. So like E is really the W for me. I'm actually going to do it for me, but we could switch it when we publish it. I just find this more comfortable on my keyboard. And so then down is D. Right is F. And then left is S. We don't need to update that. In fact, we don't need this whole thing. Last button time. Do we need that? Or if we might need that. I'm going to keep that for now. Down. I don't think we need to do that. I think we still want to do the rest of the stuff. Yeah, we'll see. If the start... Oh, so start button, we'll need to assign something for that. I'll just say T randomly, because that's close by. Okay, game time step. This one shouldn't really need to change, I don't think. So pause, that's the start button again, so we'll do the same thing with T. Current state, game over, start button again. I may keep some of this stuff because I know Scott was working on a launcher thing, right? Like a menu or something to where you'd be able to have like a list of the games on your device and then you could launch the one you want. Select. I'll just say U. Kind of like opposite of T in a way. I don't know if we'll end up keeping all of these, but and then A and B, although these are basically just going to reload. I'll do X and V, which are under my left and right buttons. Okay, if we're in the title screen, if any button was pressed, so I think if available, let's do this. Cur button val is none, and then if available, if else cur button val equals none. And then here we can say if cur button val is not none. So if any button is pressed, then show the game group. Previous buttons, I don't think we need to do. Okay. Code snake game. I think maybe that might be all we need, but I'll see. Oops. Okay. That's a good start. So that is the title screen, I believe. So any button. So I'll just, it's F. Nice. Okay, we got the snake. And I can turn. I can eat the apple. We got, did we get bigger? Yeah, we got bigger. Now we're 4. Sweet. This doesn't really need to print so much. And it's very slow right now. It could definitely stand to go faster. Oh, I think I missed. Did I miss? Yeah. So then I think this one speeds up as you play. Yeah, I feel like we just got a step faster. Oh, in fact, it's printing the speed, and you can see it's down to 0.4 now. I think we have room to start faster, though. I don't think we need to start so slow. Oh, missed it. Oh, okay. Oh. I'm not sure what happened there. I guess it must have registered me hitting myself. So I did try to turn towards the apple, and I thought it like didn't register my button, but maybe it registered late or something. So start, I think I said was T. Yeah. Play one more game, then we'll get back to the code. Actually, I might need to run to the restroom. Oh. Let me... What's up, C. Grover? Nice to see you today, my friend. I mean, it must be that I ran into myself, right? But why? I'm gonna go down. Left. Down, left. One more? Or I'll just go down. Up, right? Up, right? But it does not always well, but we have the cooldown. Oh, so the cooldown probably wrecks my ability to go, like, up and then left really fast. Maybe we don't need the cooldown for this one. Oh. I have no idea why I lost there. I pressed down. Yeah, I pressed down. D is down, right? D is down. And down is, like, working, right? Down is not making... Because, like, if I would have gone up, then I would have lost. So is down making me go up? But I don't think it is. Yeah, down is making... I'm so confused. So I went down and then left, and then I lost. Why do we lose there? So right... down. As soon as I did down that time, I lost. Okay. We need to have more information. When we catch this, let's print it. And then inside the helpers, let's add some stuff about why the game ended. So, out of bounds on the top. I'll just say OOB top. Out of bounds bottom. Out of bounds left. I mean, surely it's not the bounds, and it's the ones on the snake, but I'm gonna add prints. We might as well add them everywhere. Game over. So this is if the next lock is the sprite. So game over, hit self. I ran into. And I think those are it, right? Yeah. Okay. So now we should see more about why the game ended. I went down, then right, up, left. Left. Out of bounds bottom. I think that the world is not as big as I think it is. Yeah, actually, I think this is probably representative of the size of the world. And visually, there's nothing else. Yeah, totally. So if I just keep going, we're going to hit the wall. Right, okay. Yeah. We have an invisible box that we are inside of, which is because this code was made for the Pi Badger, which has a much smaller screen. So what we can do is inside code snake game. Yeah, it should also be visible. That's definitely true. Yeah. I'm going to go make the world bigger, but actually I guess let's solve both problems well, not at once, but let's solve both problems. So let's actually open this too. Because what we could do that would have made the... Why is this not doing anything? Okay. Maybe it wasn't. I just didn't see it. Oh, okay. So it's doing background as transparent. Let's change that to do background as a color that is not quite black. I will keep it on 0. I'm gonna export a new one actually. I'm just gonna call it new. Not feeling very creatively descriptive currently, so we'll just call that new. And then here we will use new, and we will not make. Where's that make transparent? Oh wait, that's splash. We don't want to change splash actually. We want to change sprite sheet here. New. And then this we don't need anymore. In fact, we don't want anymore. I keep clicking on this to like put my keyboard to focus on the screen so I can type into it, even though that's like absolutely wrong. Okay, yeah, this would have made the problem very easy to identify as well, so I think this is a good improvement. Okay, we do that, and then we also, 2 birds, 1 scone, or 2 birds, 2 scones. In this case, we're gonna change it to just be bigger also. So the size here is saying 16 by 20, but that's because 8 by 8 tiles, that must equal oops, 8 by 8 tiles. Also, wait, what on earth did I just do? That was like not even what we needed at all. 8 by 8 tiles. So 8 times the width, which is 20. Kind of weird that it's height and then width, but whatever. So that is set for 160. And then this, of course, is set for 128. So those are PyGamer, well, PyBadger size, but it's the same as the PyGamer. So we can actually go much bigger. We have 320 by 240. So 320 width divided by 8 is 40, and then 240 height divided by 8 is 30. So we could actually go 40 by 30 with the world size. I almost did it again, where I clicked on the screen. There we go, now it's the full size. Let me take the slower off. Wait, what is start? Start pauses? T? Does that pause? Yeah. Nice. We should have a, if I unpaused it, we should have, it should say when it's paused. It should tell you somehow. Because right now, nothing happens other than the snake stops. Which is, like, better than nothing, but, like, some kind of actual visual indicator would be nice, too. Well, like, a visual indicator specifically about pause, not just the snake not moving. I'm just going to run into the wall up here. This is way too slow. One thing I want to do is, let's speed this up a bit. I think, how fast would it go if we just, like, took the reins off? Would it be unplayable if we just, like, made it fast? What if we do away with the idea of getting faster over time for now? And let's just change this down to like 5 times faster and see if it's still playable. Is that gonna get the new code? I think it might actually. Oh, Same step, not... Oh, yeah, we need to... Wait, what did I just do? Did I just change that? Yeah, I did. Okay, we don't want to do that. We want to get another one of these. Set that like that. There we go. Okay, very fast. So one problem here is that the cooldown on the buttons is faster, or I mean is slower than the like game update, so it's hard to make a U-turn. I did it a couple of times there, but it's kind of difficult to do. Okay, so that's very fast. I don't know that we want to go that fast. That's promising though, because that means like the system itself is fast enough to do this and keep up. How should the speed work relative to the like so like getting faster makes the game harder. So I do like the idea of the further along you get, the faster you go. But I think it's not tuned very well currently because it starts on 0.5. And in fact, actually, I think it effectively starts on 0.6 because... Well, let's see what it says because it is printing the speed here. Can play again with T. Oh, okay, 0.5 it's starting on. But that's just too slow. So this is, let's see what this is saying. I just kind of glossed this over before. So it's saying get the maximum value, get the higher of the two numbers, 0.1 and 0.6 minus 0.1 times the length of the snake over 3. So every 3 segments of the snake, we get faster by 0.1 seconds. So basically, this is how long we're waiting in between the step of the snake. How long we're waiting in between the snake actually moving another step. Call it a step even though they don't have feet. A slither? No, let's call it a step. And we're basically saying at the start it's going to be 5 because we have 3 to start with, so we minus 0.1. Once we get up to 6, we're going to be minusing 0.2, so we're going to go down to 0.4 total. 9, we're going to go down to 0.3. 12, we're going to go down to 0.2. 15, we go down to 0.1, and at that point, it's never going to get faster because it will always take the max from there. No. Possible ban evader monitoring, yes. Did you get banned already and then come back somehow? It's for a person on Twitch. Does speed increase with each apple like the length? Could you have multiple apples and have a red one that slows and some greens that speed up? Oh, that's interesting. So currently so I'm not exactly sure when you said that or where I was at through this, but this basically dictates the speed currently, which is based on the length of the snake, which ultimately each time you eat an apple, the snake gets longer. So it is tied to the apples, but not directly with the colors. Green and red is interesting. So yeah, that's kind of a cool idea. I do like that idea, actually. That kind of shakes up the game a bit. Get the old Granny Smith and Red Delicious going on there. Let's try to do that. So then, yeah, we'll have green. It'll spawn both, and then the green one speeds you up, the red one slows you down, but they both make you longer. And so if you get too fast, you can eat red ones, and if you get too slow, you can eat green ones. And then that will make the slow speed to start with not so terrible because you can actually start speeding up from the first apple, right? Like right now, I think part of what's wrong with how slow it starts is you don't get to speed up until you eat 3 apples, and then you're still at 0.4, which is like still pretty slow. Like by the time you get to 0.3, it feels a little bit more reasonable, but that takes you eating 6 different apples on the slow speeds, which takes a minute. So yeah, this is actually a pretty cool idea. Let's do canvas size. We'll add another 8 pixels here. 32. Resize that. And then we need to go back to RGB so that we can use new colors. This is the official color of coffee, by the way. I don't know why it never occurred to me before, but coffee is a valid hex number and it has 6 digits, which means it's also a color. That's the official color of coffee. You might think it would be brown, but it's actually a very light teal. And with that out of the way, we can get to green, which is what we want. If it wasn't so bright, I would use it, but it's very close to white. I don't really care about the order of those. I mean, it doesn't really matter that this one is first either at this point, but it kind of feels like it should be first as the background color to me. I would not hate it to be slightly darker. It might be nice to be just a tad darker even. Because it still will contrast from the actual black of the display. So we have to go back to this and then this whole again. You don't have to do this part of the dance. We're choosing to do this part of the dance. Oh, it stayed. That's weird. I can just overwrite new. I think that's fine. And so right now, it's not going to actually use the Granny Smith, the green apple. One thing I would like to do for right now is put this inside CodePy so that I don't have to import that every time. So I think that add apple goes from here. Let's also have, well, let's change it inside here first. I think what we do is we make this also take a color, or actually let's just have it take the sprite index. That way the code is like ever so slightly more generalizable. You could have it be spawning other stuff as well, potentially. If you wanted to kind of reuse the tile grid framework thing here. So let's just say this is the Apple sprite index. And by default, it will just be the red one. But you could pass in a different one, and then it will set it here. So that's how we'll get control. We'll also need to know which one got eaten, but that's easy enough because they're going to have different indexes. So let's go add the other index actually. So Apple sprite index. So we have red and green are on the end, right? Yeah. So red is 2 and green is 3. So we're going to call this red, green. Actually, I think I want apple first. Apple red and then apple green. It's kind of backwards for English, but I like that they both start with apple, which is alphabetically the same and everything. Okay, and then when we hit an apple, which is actually handled by the world, no, is it? Where's it handled? It's handled by the, no, it's handled by the code, actually. Maybe that should be handled by the world. Or is it handled by the world? It is handled by the world. World.moveSnake, it must be. Yeah. Here. Never spell that right. check for collisions. So that's going to say if the next one is, I'm going to change this to in. Yeah, we need to actually change all of these. Okay, so if it is red or green apple, then we are going to get bigger. Okay, so one thing that is weird here, though, is we're inside world, which is not currently where the game speed tick is. Game speed time step. So that is going to need to move into world. Or the alternative is move snake could return a value that indicates like what happened if an apple got eaten, and then if so, which kind. I mean, that sounds all right. I mean, realistically, it would probably be nice to like get it to where world just has a tick function and code snake game calls world.tick, and then everything inside of there does this kind of stuff, maybe. I don't know, though, because we need to get the inputs into it still as well. All right, I'm going to run to the restroom real quick, and then I will BRB. We'll keep going. Okay, we're back. Yeah, I don't think I want to go all the way towards the full tick refactor just yet, so let's do, for now, just have move snake return some different things if we ate an apple. So we'll say result equals world.movesnake, and most of the time the result will just be none. But if they eat an apple, then it will not be none. It will be something. We still need to draw, though. So if we return from here, then we're not going to get to draw. So we'd either have to draw in here and then return. Or the other thing we could do is like make a return value. Return it from down here. Doesn't really matter too much. I think I like just returning early. So let's just call, so let's say we add an apple. So first of all, we need to know which kind of apple that we ate because we want to add the same kind that we ate. So basically I want to keep it to where there's like always one red and one green. Maybe we'll change that up eventually, but for right now I think that's the behavior I want. So we'll say so if it was a red apple, specifically, we want to add a new one, which will be the red one. The red one. Ate a red one, we add a red one. And if we ate a green one, we add a green one. Okay, then we draw. And then we return I want to return the color we ate, which is kind of a little annoying again because now we are in the same problem where we either need to move draw inside of each of those and duplicate it, or well, triplicate it because we have this down here. Okay, let's pull an audible here and say return value equals none. Return value equals green sprite. Return value equals red sprite. We don't draw. We return down here. Okay, so we set the value and then we return it down there. Otherwise, in every other case, it's going to just return none. So then for the result, we can say if result equals world dot red sprite, then do this. Elif result equals world dot green sprite. We can do this other one. And so what we'll do is I think I want to approach the time a little bit differently, actually. So I think what I want to do is just have a actually, what do I want to do? I think so one thing that I'm like contemplating is it's probably better to store the speed as an integer and then increment and decrement it as an integer and then divide it into a float at the end, rather than storing it as a float and incrementing and decrementing it as a float with 0.1s. I'm pretty sure eventually we will hit some weird roundingness and end up with like 0.4999999 instead of 5 or whatever, if we do it this way. If we change to integers, do we want bigger integer to be faster or slower? Because right now, bigger number is slower because it essentially is the number that we wait in between times of updating. But we could certainly invert it to where bigger number is faster. Speed adjuster helper, pass in -1, +1, or like minus or positive, and then it deals with it. Yeah, we could factor it into its own thing, and then it's easier to kind of tweak the behavior of. Let's see. So init. I think I'm gonna start with like 0 to 20. I think that's a decent enough range to be fine. So I'm just gonna say if 0 it's kind of backwards, isn't it? 0 is greater than speed, or speed is greater than 20. Raise value error. Does CircuitPython have an implied decimal math system where the number is stored in an integer, but the decimal point is implied, e.g. where 1 is stored? I do not know underneath the hood exactly how it works. I just know in the past I've done things where I keep a float and then I like add 0.1 to it a number of times, and eventually I end up with like not what I expect, basically. Say see if we get it off of a quick test here. I don't know, maybe we won't. Yeah. So we did 2, 3, 4, 5, 6, 7, but then instead of 8, we ended up on 7, 9, 9. 8, and then from there we went 0.1 each time to the 9 9s, but then eventually we made it to a 0.2. We're actually like keep shifting higher, basically. So yeah. If you do those as floats, you end up like that eventually, whereas if instead you say val equals 1, and then you loop still, and then you go val plus equals 1, and then you go print val over 10, get the expected values all the way up. Okay, so we check the range, 0 to 20, and then we go self.speed equals speed, and then what we're going to do is have a property called, like, delay? Which is going to return a float between... I don't think we really need to go any faster than 0.1. That's pretty darn fast. And I don't necessarily want to go any slower than 0.5. So I think our actual range is 0.1 to 0.5. Let's make a... We're just going to return 0 to make that valid for now. Okay, how does this work? We want to... We can actually just look in simple IO. This is implemented in simple IO. We could just grab the library, but it also has a bunch of other stuff we don't really need. Jepler's udecimal works like CPython decimal. Oh yeah, I forgot about udecimal. That was really interesting. Clean integer division, giving a clean rounding in decimal style when printed compared to the float usage. I wonder what the different code looks like. Yeah, I'm not sure how or why that happens, but I just know that I ran into it before. But I do suspect Jeff's microdecimal thing, udecimal, probably would allow you to do that without the weirdness. Basically, just going to take this. Okay, so then delay is going to be... Okay, maybe one problem actually that we have is we'll be mapped backwards, will we? So we're going to get x is going to be 0 to 20. So for now, let's keep it to where lower is faster, because that's going to make this easier, but we could still swap it, I think, at the end. So we are going to return map range. Call map range, turn the value from it. The input is going to be self.speed. The in minimum is 0. The in maximum is 20. The out minimum is 0.1. And the out maximum is 0.5. Unresolved attribute. Does this have to come first? Oh, because we're in speed adjuster. Also, this doesn't need to be like that. And then we can also have def increase speed if speed is less than 20, it gets bigger. Def decrease gets smaller. Okay, so let's make a speed adjuster. I think it wants the speed to start on, right? And I guess we'll say that we start at the slowest, which is 20 currently. Excuse me, I just arrived. What's the weirdness? The weirdness is the if you plus... have the code still here. So if you start with a float like 0.1 and you for loop 100 times and you add 0.1 to it, so you continually are adding those floats together, you eventually get like off by a tiny bit or whatever. And then you kind of come back for a while and then you get off again for a while. Then eventually you're off by even further here on the end bits or whatever. Whereas if you use an integer and you loop and you plus an integer, but then you divide, you get all the expected numbers. All right, so we have our speed adjuster. If we ate a red apple, then we want to decrease the speed. If we ate a green apple, then we want to increase the speed. We don't do this. We don't really need to do this either. Maybe eventually we'll go back to printing it, but I don't think we need that for now at least. And then here, instead of game time step, we are gonna be... Actually, we should cache this. We should not recalculate it every time. Should not do this. Instead, we should have self.delay equals this value. Delay just gets returned, and then when we increase here, we always update delay. Float, let's see. Float arithmetics. I guess that's interesting. The interesting bit is how it chooses the precision to show. Floats always being bad representations. Okay, so here, now we set the delay as a number and we don't keep calculating it over and over. So then, when it is time here, instead of saying prev time step, we would say speed adjuster dot delay. Okay, does that work at all, even a little bit? No. Okay, I forgot to go and change those, actually, though. So that's pretty fair, I think. So default, we'll just say red. Okay. All right, and now it actually runs. I think it won't. I think it will only place red apples currently. Which means we will basically never go faster. So we're not going to play very long. We're just going to hit the wall here. And then we can start spawning green apples also. So whenever we add an apple here, we're actually going to... I mean, it has the default, but I am just going to explicitly say that we are adding the red apple and the green apple. We add one of each. And then whenever, we should already have the code that says whenever we eat one of them, the correct one spawns. So let's not eat, well, yeah, let's do eat the red one. We'll grow. We won't get any slower because we're already at the slowest speed. It might be nice to have the apples not spawn on the very edge. Is that too nice to the player? I guess the original snake sometimes sticks you on the edge. The edge is the hardest, though, because you got to go until the very last second and then down. And I'm also playing through the delay of the webcam here. I'm looking at my screen here, not the actual screen. Okay, so we should have just gotten faster, I think. This looks a little washed out here. It looks like it's still printing 5, though, so I don't know that it actually worked. Oh, you know what? I think we need to subtract. I think I'm going the wrong way inside of increment and decrement. Because we decided that 0, the lower the number, the faster you go. Well, actually, we did change to 0.4. Or is that just still printing the old values? Too slow. Or too... I turned at the wrong time. Ah, I did it again. I'm gonna eat a few more greens, because I'm trying to decide, like, am I actually getting faster, or is that thing just printing numbers that aren't actually associated with the speed right now? I don't think I'm getting any faster. Of course, it didn't change again yet. Yeah, I guess we did. We totally did. We did. Just the way the mapping works, it does basically still work out to where you kind of have to... you kind of have to get quite a few. How come we're not using more of the range though? How come we're always set to 0.10? Oh, because I divided by 0.10? I divided by 10? Like, how come we're not ending up on like 0.25, 0.26, 0.27? Oh, okay, we just sped up again by eating a red apple. That's not right. We might still be on the old version of the code, honestly. All right, now that we're going this fast, I'm going to... Oh, we don't have a green one anymore. I don't know why the green one's gone. What happened to the green one? Oh, okay. Oh, thought it was a goner there. Oh, got my tail. Okay. Why is that not working? Was I changing it? Maybe I was changing it in Code Snake Game. Changing it in Code Snake Game? I was. That's kind of annoying. Okay. Let's take all of that and put it here. So did I change? So are we like further out of state now? Yeah, because now we don't have... Wait, now we don't have the green apple. We end up with like a mashup? I did some of the stuff in CodePy and some of the stuff in Code Snake Game. We don't have the speed adjuster in this one. Okay. After I get this all fixed, I'm gonna close Code Snake Game. Does the IDE... Let me see. Long term, maybe the user could choose the number of greens or built-in mechanics. Still one red, which could appear later, but for a while, slowly flash and disappear right away. Oh, that's interesting. The red is like a reward to help you slow down. That's kind of a cool way to do it. Oh. Yeah. Yeah, the IDE does have a compare. I could have used it. It probably would have made this a little bit quicker and easier. But in this case, it wasn't too many lines, and I just kind of went for it. Yes, we need to not do that, huh? Why don't we... So, honestly, it seems kind of silly that we... Well, no, we need to pass the snake because the snake is a different object. Maybe world should, like, have a snake instead of code having a world and a snake. That's probably a better way to do it, honestly. Like, realistically, snakes should probably live inside of world. And then add apple would not need to accept a snake. Whoops. Because it could just say self.snake. But I also don't want to start that refactor while we're halfway through this other thing. So I'm going to leave it for now. But then what we will do is... How do we want to do it? So... Let's see if that works for starters. So we need to check. So it should be easy enough. We can just check inside the world if the tile that we randomly chose for the apple already contains an apple or not. Okay, let's see. We're not printing the speed anymore, but I'll play for a second here and see if I feel like I'm speeding up. So far, it's still pretty slow, though, I'll tell you that. Did I overshoot? Don't necessarily feel like I've gotten that much faster. Although, actually, we still do have the problem that I was talking about before, which is that they're backwards. Yeah, red's probably going to speed me up, actually. That's a good point. Basically, my increment and decrement functions are backwards. Well, they match their name, but they actually should be opposite their name, technically, for the behavior we want. So yeah, red is going to call decrement, which is going to actually make us faster in this case. And yeah, I do actually feel a bit faster already. Totally. Okay, let's go back to printing the speed. It's kind of nice. Or, yeah. How about we print it when it changes? How about that? We don't need to print it like every frame of rendering, but maybe when it changes. Okay, close this. Actually, while we're here, speaking of the compare, let's do a compare and see if I missed anything. Oh, okay, guess you can't do it from this menu. Maybe it was there and I just didn't see it. All right, white space, I don't care. Interesting. Okay, yeah, we want that. Okay, I'll tell you what I'm going to do is I'm going to take CodePy, I'm going to put it in Code Snake Game, and then I'm going to close Code Snake Game. So then now we're always changing CodePy. And then when I'm done, I'll update it. I'll take the copy of CodePy at the end, and I'll put it in Code Snake Game so that it's there as well. Okay, fix the decrement and the increment. So let's say in our speed adjuster, we want to make this one minus and this one plus. Or the other option would be we could like reverse it somewhere else, but I think I'm going to do it here for now. And then let's also say whenever we calculate this, let's print the current value. We can just get a sense of where we're at. So this time green should speed us up. It is, I mean, it's awfully slow still, especially with how big the screen is. We may still want to go faster by default. Oh, it didn't print. Why didn't it print? Why didn't it print? Oh, also the, okay, I took focus away and then wrecked my ability to do this. Also, these are backwards. Okay, there we go. So now we do have the smaller numbers. So we're on 0.48. We went down by like only a tiny little bit there. 1/20th of half a second, basically, or 20th of 0.4 seconds. Definitely start faster. Yeah. Figure out the right keys before you crash. You know what we could do actually is on the title screen, it should print the, it should say the keys. That way you know what you, before you even before you even go, it shows you the keys. Or the other thing we could do is on the title screen, we could have it say press up, down, left, right to start the game. And that way you like prove that you know what the keys are, basically. I will say this is awfully slow. Maybe we want only 10? Maybe we want only 10 steps instead of 20 steps? Or maybe 20 steps is okay if we start faster. I do kind of like the degrees of freedom, but I think we definitely want to start faster. So maybe let's take the top end down to 0.4 and see how that feels. That takes out like 10 apples to get to the same speed, I think. Let's also make a min max and then use those so that we can change them later in one spot. Too far. That's like the most inconvenient thing to replace because it just does not want to highlight everything with one action, no matter how I do it. Why do we have 3 of these? Oh, because the one we start on. Yeah. Okay. We should be a little bit faster to start with now. Yeah, totally. Yeah, I think this is good. It still feels fairly slow, especially on this size screen, but I do think we don't want it to be like super punishing right out of the gate. Yeah, 385, so we're going to be doing 0.15 per apple. So we'll go down to like, what, 3.6? What is that? That's, how many apples per 10th of a second is that? Oh, 3.7, my bad. I was off by 10 there. Well, 0.10, but 5. So 3 apples got us halfway through a 10th. So 6 apples should be a 10th of a second, which gets us to 0.3. We actually speed up. We accelerate slower with this one than the old one, but we have a wider range. So we have like a more middle zone where you're kind of going sort of fast, but not super duper zoomies. I do kind of like the middle speed a bit here. One thing that would be cool is show the score on the screen. Well, we show it on the end screen right now, I guess. But it might be cool to like leave 1 or 2 rows off the bottom or top and have a like title bar type thing with the score visible and maybe the name of the game, right? It could say Snake. That top actually sounds kind of cool to make it like a title bar sort of thing. If we did that for all the different games we made, then it would sort of increase the feeling of a sort of like console system type thing, maybe. Not that consoles have title bars, but I guess really what it would do is increase the feeling of a sort of desktop type environment. Maybe we should let them go a little faster than 0.1. Should we let them go down to like 0.5 if they keep eating the greens? Especially now that they're in control. Wow, that's going to be a hard one, kind of. Okay, there we go. Actually, it's not as hard as I thought. Oh, okay. I was like, he says right before he messes it up. Nope. Okay, we're at 0.1 now, so we're at the minimum. Well, we're at as fast as we can get. So we should be able to eat the red now to slow down. Yeah. I do think we could stand to let him go a little faster. Now that they are in, like, direct control and they have a mechanism to slow back down, I think there's room to say we can, ooh, this is a dicey maneuver. I think there's room to say we can change the maximum speed to be a little bit faster. Seriously, I'm off by 1? Oh, that's going to be tough. Okay. Whew. Wait, that's the second one of those in a few seconds, isn't it? Oh, missed it. Another one. All right. The L bend. I'm going to call that move the L bend. Wow, that red is hard. That is in the corner. Oh, we still need to add logic to make the apples not spawn on top of each other. Thank you, by the way, whoever said that. I think you're totally right. Oh. Correct that one a bit. But we're getting kind of long here. Yeah, I could see a world where it would make sense to only spawn the red one every few times or something. Like maybe it spawns the red one after every 3 green ones, and then, like you said, if you eat, you know, maybe if you a certain amount of time, it rots away. So you have to get it within 3 more apples or something, or it goes away. Oh. Close. Got up to 43. Not bad. Okay. Let me catch up on the chat here. Okay, actually, it's not too far. Be nice if it starts in larger chunks, gets proportionally less, and red gets more effective with higher speeds. It starts in larger chunks. Oh, kind of like logarithmic on the speed. The first couple green apples make you take a bigger step than the next ones. Just have red off screen for 10 seconds or so, and it will feel like an eternity. That's true. Yeah, spawn it. We could spawn it out of bounds and then move it into the boundaries after a certain number of turns. Or if we want to, if we want to cross universes, if we want to go, what do they call that? I don't know the right name I'm trying to think of, but if we want to go cross universe, we could have the red one spawns as a seed, and then over a certain number of turns, it like grows into an apple, and then you can eat it. That way you get to see it as it kind of like grows for you, instead of just being invisible and then suddenly visible. You have like visual cue of like, you know, just planted, not ready yet, not ready yet, not ready yet, almost ready, almost ready. All right, finally it's ready. And we could have sprites that get progressively bigger from just a seed to a full square, because we have 8x8 to play with the current sprite sheet. We could make bigger sprites too, honestly. This was made for a much smaller screen. Although by the time it gets scaled and everything, honestly, I think the size we're at's pretty good. I'll change the title screen to fit, but as far as the actual size of the sprites, I think we're actually pretty good here. Maybe I don't want to do 16 by 16, which is probably what I would go up to if I was going to make them bigger. The logarithmic thing would be cool. I don't know if that's a proper usage of the term, but in my head I think it is, so I'm gonna go with it, even if it's not. The thing where the first couple apples speed you up more than the ones that come later would be pretty cool, but I don't know an easy way to implement it. Because right now we just have a straight mapping. Somehow you'd have to like add a bias to this where you could say like bias it towards the bottom range, you know, the bottom end of the range or something, or the top end or whatever. Actually, we still have. Oh no, that's just like 50%. Okay. Yeah. It's like we still have a hard-coded 0.5, but that's a different thing. How about we start a little bit faster, but we give them the ability to slow down? Yeah, so now we're moving faster, but if we eat red apples, we could get back down to where we were. And, you know, notwithstanding, we're talking about maybe changing how frequently the red apples spawn. That could still come into play here. So this way you actually have room to get slower from the start. You know, another thing that we could do, okay, here's what I think I might like this. I think I might like this the best. What if we keep it so the red apples are always there? So you always get the ability to slow down if you want. But when you eat an apple, so like right now, the way the score mechanism works is I think it's just counting the segments of the snake. But we could actually keep a proper score variable that is separate from the number of segments. And within the score, we could give you a bonus for going faster. So like when you eat an apple, if you're traveling at top speed, you get more points than if you eat an apple and you're traveling at low speed. So it's like kind of up to you, the player, to make the trade-off of go faster means you get more points, but it's harder to not lose, or go slower, which means you get less points, but it's easier to not lose. Like it's easier to not run into yourself. And you kind of get to choose how you want to play, which strategy you think will be best for you. I think I like that. You could still tweak it up to make it say even within those bounds, you could also still add the red doesn't always spawn. Or you could still also do the seed thing like I was talking. But I like this idea of like the bonus. That way you're incentivized to want to go faster, even though it's easier to go slower. Maybe then think of a tree in the middle with a single pixel apple that grows to 2, 3, then fall and bounce around. Oh, that'd be interesting. You have the apple tree is in the center, and it kind of like grows the apples, and then they fall when they're ready. Be interesting. Okay. I gotta run to the restroom again. We only have a few minutes left, but I don't want to wait that long. So I will BRB again. We'll probably wrap up here before too long. But I do still want to fix the apple spawning on top of the other apple. So I'll BRB. We'll fix that, and we'll see how much time is left after that. So BRB. You know what might be cool as a library would be a NVM backed high score library. So you could have a library where you just say like import, high score, and then you could say high score dot set score, and you give it like a game ID and a score, and then it will go into the NVM and it will keep track of all the game IDs that you've set and their current high score. And that way you can have like one little storage thing inside NVM that could actually keep high scores for a number of different games. And then all those different games could also just say, import high score and then get the high score for this game ID. Theoretically, it could be a list as well instead of a single value if you wanted to. I don't know how much NVM storage there is on all these devices. You can get the size, I think, actually, though, right? Wait, is it on microcontroller? Is it? I don't remember. Getting way off the track of what I was talking about before, but 4,000 bytes. You probably have enough to do a couple of lists. Depends on your IDs a little bit. I was imagining ID being a string, which would take more space than if you did numbers or something, but numbers would be harder to keep like guaranteed unique, so I don't know. I don't know the right way to go about that. I guess it'd be good to measure, like, let's take the approach of string and list that holds, 5 scores or something, and then see how many games would fit. And if it's like you could still fit 100 games, then it doesn't really matter. But if we use a string and we store 5 and you can only fit like 3 games, then it's like not really worth it to have it be a string. And it's also probably not worth it to store 5. We could just back it off to be just a number and another number for the score. And we should have enough to store a lot. Yes, spawning the apples. So when we call add apple, we want to make sure that there's not already an apple at that location. So while location is none, or location is in snake locations, or self location actually we could simplify this. We could just say while location is none or self location is not equal to an empty tile. So if it's a snake tile, that should count for it. If it is an apple tile, that should also count for it. I don't know if you can do a list. I guess we'll find out. That seems fine. Of course, we'd never know if it works until we play enough and just like see if it ever spawns on top of something. But we can't like necessarily prove that it's working very easily. It might be cool to have the head, like the first tile on the snake, first segment, look different. Maybe we could have a little blink ahead looking thing, vaguely. I mean, it's 8x8, so like we're not gonna be getting too artistic within those bounds, I don't think. But there could be room for it to at least look a little different than the body segments. Okay, I mean, We haven't spawned on top of itself yet, but obviously this was a very low percentage chance anyway, especially with the size of the board. I guess that's how we could make it a little bit easier to try to test that it's working, is we could make a much smaller world, and then that would increase the chances of a collision here, which this should help filter out. I guess we could also add a print statement in here. That would be how we really prove that it's working, is we add a print statement in here so we know when it skips. And then we'll know that it's working. We could even print the location so we could figure out why it skipped if we really wanted, but I think that will be an exercise for future Tim. Okay, I'm pretty happy with how far we got this. So thank you to everyone in the chat who gave up some ideas. I appreciate all of those. What was it? T to start again. So yeah, let me just run through real quick for my own sake stuff I still want to do. A new title screen for sure. Change the score to not just be 1 per segment and instead reflect your speed, so giving you a bonus for going faster. Keep track of the high score, but I do think I might want to do a library for that, like I was talking about, because that way it can be used by more than one game. And then maybe change the head. Maybe change the head tile would be cool as well. I think those are the main things I want to do. We could still tweak up the red one. Maybe I'll play with that a little bit. I probably don't want to go too far down the road of playing with how, like, when the red ones spawn, because truth be told, I'm like I could lose a lot of time doing it, and it doesn't matter too much for the example. But I will of course publish everything, and folks can tweak the game however they want, obviously. But that's definitely the kind of thing where I could like hone in and change it and play the game 100 times in a day and keep changing it until it gets to be where I want it exactly. And then I'm like, I just spent a whole day changing how often the red apples spawn, which is not necessarily the best usage of my time, but my brain likes to do stuff like that. Yeah, okay. That'll do it for now. Thank you everyone for watching. Again, thanks to the folks in the chat for dropping some ideas. As a reminder, for the next 3 weeks on Deep Dive, I'll be there. So Fridays at 2 p.m. Pacific, which is what Deep Dive is normally billed in. That is 4 p.m. Central and 5 p.m. Eastern is the Deep Dive over on the Adafruit channel. I'll be there for the next couple of weeks, 3 weeks. And then I believe Scott will be back at least for a few after that, maybe, although I haven't talked to him specifically about him, so maybe not also. I'll be gone on Saturday next week. So yeah, Deep Dive on Friday, no stream on Saturday, but then I will be back again, Deep Dive the next week, and I believe I'll be back on the Saturday as well. But that's also a couple weeks away, so things could change. For now, that's the plan though. Deep Dive next week, no Saturday stream. Deep Dive the week after, and maybe Saturday stream. I'll see you later. Hope you have a good day and a good rest of your weekend. Thanks again for watching, and I'll catch you next time.